In this video, I will show you how to capture and process video from an iPad or iPhone so that it can be used in the application Vernier Video Physics. We will then export the data and do some analysis on it. Currently we are looking at the screen of an iPad. There are two software packages here that we'll use. The first is Video Physics, which we'll use to do the video analysis, and the second is Graphical, which is capable of producing more sophisticated graphs than the Video Physics app. Let's start with the Video Physics app. The first step in this project is to take a video of a sporting action. In the example, the handsome chap pictured is about to kick a football. Note the yellow tape measure placed at right angles to the field of view. The ball or projectile must also be launched in this line, otherwise an error will be introduced, because the ball will be travelling toward or away from the camera. You will want to experiment with framing the picture and the distance from the camera to the projectile. The size and speed of the projectile will influence this choice, as will whether or not you want to see the projectile land. Once the video has been filmed, we are ready to start plotting points frame by frame. Open Video Physics and press the word Experiments in the top left corner. The plus sign lets you either take video or get it from an existing source. I have already loaded the video, so I will exit that menu and select the experiment that I intend to use. You'll now notice that the video has crosshairs superimposed. To plot the first point, put your finger in the outer shaded circle area and drag the crosshairs so the ball is exactly in the center. Once you are happy with the position of the crosshairs, tap the outer shaded ring. The point will be registered and the video will progress to the next frame. Repeat the process, drag the crosshairs, center the ball, then tap the outer circle. In this case, the football is close, so it makes it quite easy. If the ball is similar in colour to the background, or it is small, or it is far away, this will be more difficult, so think carefully when taking your video. I won't bore you with the details here, so I will now stop the video and come back when all the frames are finished. Okay, well we're back now. All the points have been plotted. Note that I've made a deliberate mistake with one of the points that we shall fix up shortly. But first I want to show you the slider control and the forward one frame and back one frame buttons. The slider is this long bar down the bottom of the screen. The slider makes it easy to go backwards and forward through the video, and we can potentially stop it where we want to be. That's pretty close. Then we can use the forward one frame and back one frame button. They're the double-headed arrows you just saw flash. When you press it, you'll see a red dot change to yellow, indicating that that point can now be edited. Now you can see that point there is actually out, so to fix that, drag the crosshairs so the ball is centered and tap the outer ring just like before, and that's fixed. And the video has progressed to the next frame. Now all the points are correct. It's time to set the scale and origin. On the ground down here, you can see the tape measure. It is set at 3 meters long. You change this setting up the top of the screen where there is an origin and scale item. Push that and it shows that 355 pixels is equal to 3 meters. And that's the length between these 2 points here, which you set by dragging these circles around. You will set your own scale using a similar item of known length and enter its length into the scale setting, so you might have something like 2 meters set up there. We can also set the origin of the X and Y axes by dragging this large circle down here. It doesn't really matter where the origin is, but it's probably best to set it somewhere near where the football is being kicked. And with that, this program can scale and calculate appropriately. If you look in the top right corner, there is a little graph icon. Select that and we can see the vertical displacement of the ball plotted against the horizontal displacement. Be careful to note the y displacement is scaled differently to the x displacement, so it looks a bit steeper than it actually is. You can easily see where the ball was kicked, close to the origin. You might also notice that the points aren't exactly lined up, but they're certainly accurate enough for our purposes. Swiping the screen brings up another two graphs, the top being the x displacement versus time, and the bottom graph being the x velocity versus time. In the top graph, we can see the ball slowly increasing displacement while the ball is being carried, and then its displacement increases at a faster rate after it's kicked. In the bottom graph, we can see the ball is initially moving with a slow constant velocity in the x direction, then it accelerates rapidly to a fairly constant velocity. We would expect the final part of this graph to be straight, so it is likely that the wobbles are due to error in the experiment. Note that the acceleration occurs from about 3.5 seconds to about 3.6 seconds. This is the period of time that the ball is in contact with the foot, and is a potentially good focus for research. Different kicking techniques may have different lengths of time where the ball is contacted. Swiping again takes us to the final pair of graphs. This time it is the y displacement versus time and the y velocity versus time. The first graph shows the ball falling and then rising, but slowing down due to gravity. The second graph shows the velocity component in the vertical direction is initially negative as it falls. The velocity is still negative for the first 0.05 of a second or so during the kick. Then it accelerates rapidly to about 7.5 meters per second and begins slowing down as it continues to rise. That's all the analysis we can do with this application, but we can export it to other things. We can either email it, say, to our Gmail account, or we can export the data, the raw data. I can export to this program called Graphical, which is also done by Vernier. And this graphical program gives you a little bit more flexibility in terms of what you graph. We can see both x and y displacement are on the same graph here versus time, and we also have in the bottom graph x displacement and x velocity and y velocity versus time. We can add extra graphs. There's a few functions here. It's a good program to fiddle around with and just see what you can do. That's part of the exercise, is to experiment with this and just see what sort of graphs you can draw, what sort of statistics you can get. If you see what I've just done here, I can take the x velocity off and put an x displacement versus x velocity, if that's what we are inclined to do. You can also highlight areas and get statistics for those areas. These are summary statistics which probably won't be used in our particular exercise, but it's good to know they're there.